everyone, it's Blaine, and today we're gonna discuss about an integrated remote sensing, petrology, and field geology analysis for Neoproterozoic basement rocks and some parts of the southern Egyptian Nubian Shield. Why is this research important? The Egyptian Nubian Shield is part of the Arabian Nubian Shield, and this area is known for its ancient rocks and mineral deposits like gold and copper, and this basement rocks dated back to the Neoproterozoic era, and that is about 1,000 to 541 million years ago, and that is when the Earth experienced a massive geological transformations. And by studying these rocks, scientists not only understand Earth's tectonic evolution, but also identify areas rich in resources essential for economic development. Okay, so the goal of this research is to map and to analyze the geology of the basement rocks using advanced tools and techniques. And specifically, it seeks to first, number one, is to identify the types of rock present. Two is to understand their formation and the formation history. And third is to explore the region's tectonic activity and mineral potential. This research bridges cutting-edge technology and traditional fieldwork. It examines rock formations through three lenses. First is remote sensing, using satellite images to identify large-scale geological features. Second is petrology, because studying the composition of textures of rocks to determine the origin. And then third is the field geology, because observing rocks on site to confirm and refine findings from remote sensing. So I just wanted to clarify how remote sensing is very connected to the geology. It is because remote sensing is a specialized tool that we geodetic engineers use in our field. For the methodology, so here is how the researchers work. First, they use the remote sensing. They use high-resolution satellite images like Landsat 9, OLE 2, and ASTER data to map rock types and identify geological structures such as the folds and folds. A spectral analysis help distinguish between different minerals based on their light reflection properties. Second, this research uses the petrological analysis, wherein rock samples were collected and analyzed under microscopes to study their mineral content, textures, and formation history. Third is through field observation. Geologists visited the area to validate remote sensing data to measure rock layers and map structures like fractures and folds. Okay, so the finding of this research is that first, Wadi Samadi Wadi Amtandaba district contains Neoproterozoic basement rocks that is overlain by Phanerozoic sedimentary rocks. It is located in the southern portion. It is between the latitudes of 24 degrees, 56 minutes, and 25 seconds north, and the longitudes of 34 degrees, 46 minutes, to 34 degrees, to 52 minutes and 30 seconds east. Second, according to the field and the petrographical studies, district is occupied by metamorphic rocks that are dominated by serpentinites, metavolcanics, arcuated metasediments, metagavro-diorite complex, while the magmatic assemblages include granodiorites, biotite, monzogranites, alkali falsar granites, younger felsic volcanics or the rhyolites, and intrusive young gabbros. Note that the metavolcanics are represented mainly by the metabasalts, while arc-related metasediments are classified into three types, which is the tremolite schist, sterolite kyanite biotite schist, and the myrlonitic schist. Myrlonitic schist. And third, there were over 75 rock samples that were suitable for Landsat 9 sampling that were collected. It reflects the various geological units in the region, and the authenticity and correctness of the Landsat 9 images were demonstrated when the field samples when compared to the findings of the Landsat 9 images. The new approaches were successful in mapping research areas rocks, as evidenced by a comparison between the findings from the suggested Landsat 9 methods and the fieldwork. So this suggests lang no that the petrographic mappings of the Arabian Nubian Shield and other dry location may be done quickly and affordably using these approaches. In this study, the spatial distribution of the basement rocks was investigated by using the Landsat 9 data and the geospatial technologies of principal components analysis and the band ratio. So based on the deep learning algorithm, AlexNet were applied to produce an accurate, well-detailed geological map, and the CNN algorithm reported an overall accuracy of 95.27% and a kappa coefficient of 0.94. So this cartographic approach presented to generating results is interesting and reasonably validated by existing fieldwork and geological maps. So the study indicates that the use of CNN would enhance remote predictive mapping as an effective tool for regions with difficult access. For our conclusion, this research is a testament to how modern technology and fieldwork can unravel Earth's ancient mystery. So the detailed mapping of the southern Egyptian Nubian Shield not only enriches our understanding of geology, but also offers a practical benefits like guiding resource exploration. So why should we care? Studying geology isn't just about rocks. It's about understanding the history of our planet and finding resources essentials for industries and livelihoods. The study highlights how Earth's processes billions of years ago still impact us today. So thanks for joining this journey through ancient rocks of the Egyptian Nubian Shield. If you're curious about geology, science, or natural world, don't forget to like, subscribe, and share this video. Let's keep exploring together, guys. Bye!